Okay, so today we're going to look at percent composition, and remember percent composition is looking at how much each element is present within a compound or a molecule. So for example, we use magnesium carbonate in our notes, and so I can ask you to find the percent composition of this. And so what we are going to do is we're going to look at the percent of each element and how it is involved in the overall composition of this compound. So first thing we do is find the formula mass. Remember, this is measured in grams, and it's just pulling the atomic masses off the periodic table. So I have one magnesium atom, so I have 24.31 times 1 carbon atom, so 12.01, and then 3 oxygen atoms, 3 times the mass, 16. And when I add it up, I get 84.32 grams. This is 100% of magnesium carbonate. Okay, so now I want to see how much is made up of magnesium, how much is made up of carbon, and how much is made up of oxygen when within this particular compound. So I'm going to split it up. Okay, so I take magnesium, and it's just basically doing part over whole. It's like if you were looking at your grades. How many points did you actually get out of the total possible amount? So magnesium had a 24.31 mass, and I put it over the whole, 84.32, and I multiply it by 100 because we are looking at percentages. And if you plug this into your calculator, you would get 28.83%. So I know out of 84.32 grams, or out of whatever sample that I get for magnesium carbonate, 28.83% is always going to be made up of magnesium. So then I do the same thing for carbon. I do part over whole times 100, and I would get 14.24%. So any sample I get, 14.24% of magnesium carbonate is made up of carbon. And then lastly, I do oxygen. So I have to do the full amount, or account for all of the atoms present. So 3 times 16 divided by 84.32 times 100. And I get 56.93%. And I know that I've calculated all of this right because all of the percentages should add up close to 100%. Usually, if you're between a 99.9 to 100.1%, you have it correct. Okay? So very simple. It's just a lot of work, a lot of steps. Occasionally, you will be given problems where you're just asked to find one thing. So if we were looking at, let's say, octane, and octane is represented by C8H18, and I asked you to find the percent composition of just carbon. You don't have to do each individual element now. All you have to do is start off with adding up the formula mass, so 8 times 12.01 for carbon, plus 18 times 1.01 for hydrogen, equals 114.26 grams. And then from there, I can just find carbon's amount. So 8 times 12.01 divided by the total 114.26 times 100. Now we'll get 84.09%. And so I don't have to do all elements because it was asking for one specific one. With percent composition, we can also look at hydrates. So let's look at barium chloride and its hydrate. Remember, a hydrate is basically a compound that is engulfed or surrounded by water, and some compounds naturally do that. We'll talk about this more when we get to empirical formulas. But with this, we do not treat this dot as multiplication like we would in math. This just means we are adding the mass of barium chloride and water. So I know that barium's overall mass is, I believe, 137 see, 137.7, or 0.3, sorry. So I have 137.33, and that's barium, plus 2 times chlorine's mass, plus, and then remember to FOIL this out, so 2 times 2 is 4 hydrogens, plus 2 times 1, which is 2 oxygens. So when you add up your formula of mass, you should get 244.27. So what I could do here is I could ask for each individual element, or the problem could say how much, or what is the percent composition of water in a barium chloride hydrate. So what I would do is I would just look at water. So I have water's amount, 2 times 2, which is 4 hydrogens, plus 2 oxygens, and that will all go on the top because that's all of the water molecule that I have. So basically it's this whole section right here of your formula mass. And you're going to divide that by your total amount that you have times 100. So this should come to about 36.04, and when you plug it in your calculator you should get 14.75%. So, of my barium chloride hydrate, 14.75% is made up of water. Okay? And then the last type of percent composition problem you can get is more of a word problem. So I can have a problem that says calculate the mass of sodium in kilograms in 1,300 kilograms of sodium chloride. So I just want to know sodium's amount in this particular sample that I've been given. So the first thing we're going to have to do is find out how much sodium is in sodium chloride, because remember that it's not evenly distributed amongst each element, because each element has its own mass, it has its own specific ratio when it comes together. So we have to find the percent composition of sodium first. So I know sodium is 22.99, and sodium chloride's formula mass is 22.99 plus 35.45, so we end up getting 58.44. So we put this at the bottom and we multiply it by 100. And when we do this, we should get 39.34%. So this means that out of any sample I get of sodium chloride, 39.34% will always be made up of just sodium. That means the remaining amount, so roughly 60%, is chlorine. So I take the amount that they give me, or the sample amount that they give me, and I multiply it by the decimal form of my percentage, because I know I only want 39.34% to represent my sodium. So 1,300 times 0.3934, and when you plug this into your calculator, you should get 511.41 kilograms of sodium. And remember, significant figures, we go all the way back to the number they gave us in the problem. 2 sig figs here, so I want only 2 sig figs, which means I have roughly 510 kilograms of sodium within 1,300 kilograms of sodium chloride. Okay, so percent composition, very easy, just very detailed. Small mistakes usually is what causes students to get this wrong. My suggestion is to practice problems like this. So this whole part C right here has several different examples. 1 through 5, you are finding percent composition of each individual element within these compounds. In 6 through 17, you're looking at individual elements or water. And then 18, 19, and 20 is more like these difficult problems that I just gave you, word problems, where you're given a specific sample and you want to know how much of one element is in that sample. Okay?